Okay, let's see how you did so far. Maybe we can, as a class, work out an intermediate solution that you then can use for the final solution. So we began with this condition of equating marginal satisfaction per dollar spent on coffee and cake. And we found that on a stressed condition looks like this. Y squared divided by the price of coffee, which is 6,000 tenge. And the marginal satisfaction pertains to on per cake is x times y divided by 2,000. Now we want to solve for the amount of coffee and the amount of per cake that Anastasia is buying. So what is the natural thing to do at this point with this condition? Yes, divide both sides by y. Good. So our condition boils down to this, and then we can solve for x by multiplying both sides by 3,000. Times y. In other words, x is equal to y divided by 2. So that's progress, but we have not yet specified the exact amounts of x and y of coffee and per cake that Anastasia is going to buy. So what should we do to solve the problem now? Well, it appears that the predicament is that we have two variables to determine, but only one condition to use. So we need another condition, an equation that is independent of the first one. This is our first equation. So where will we get that condition? Yes, let's get it from the business constraint. And then we will have two independent conditions. So we should be able to solve separately for x and y.
Professor, excuse me.
Yes, I can hear you.
I wrote my solution in the chat, just in case if you check.
Oh, okay, good. So what is your solution?
So first of all, I found the budget constraint line. It's the result is 2x plus y is 30. It is the budget constraint curve.
Good.
And for marginal rate of substitution, I I took the price ratio 6,000 by 3,000, and it equals to MUX by MUY, and it gives me the equation of Y divided by 2X.
Good.
It equals
Y is equal to 2x, yes, go ahead.
So the result, and I took these both equations of marginal rate substitution and budget constraint line, and I got X equals 5, demand for X is 5, and demand for Y is 20.
But you have the right approach. The numbers may be a bit different. However, would you tell me your first name? I can't determine from the screen your name. Could you tell me your first name?
Nuray. It is Nuray.
Nuray Salino.
Yes.
Okay, good. So yes, you're more than halfway there.
Okay.
So in this case, we have a price of coffee, as Nuray says, of 6,000 tenge times the number of cups of coffee that we are buying, and the same thing for Y.
I'm sorry, Professor.
Go ahead.
I think you missed one number. It is the marginal MUY is 2XY.
That's right. Just
and in the
right there.
I mean, in the beginning, when you made the this like you missed 2 in the beginning of the square. No. Yes, here. Yes, on this line.
Oh,
2.
yes, good. Thank you. That's right. Thank you.
Welcome.
So we have 2x over 3,000 equal to y over 6,000. So if we use that solution, y is equal to 2x times 6,000 divided by 3,000. Is that correct? So y is equal to 4x. Okay, so far. So now we can bring in the budget constraint. The price of X is 6,000 times X and 3,000 for Y. So what is our next step? You're doing very well, right? So what do we do next?
We divide the whole equation by 3,000.
Or let's substitute for Y. We know that Y is equal to 4x.
Oh, yes.
Okay, so far. So 90,000 in this case is 6,000 for X plus 12,000 again times X. And so 90,000 is equal to 18,000 X. That's correct so far. So I get that X is equal to 90 divided by 18. Or 10 divided by 2, or equal to 5. And I think that's the solution that Levi had. So what is Y in this case?
Y is 20 because it is 4 times bigger.
Or 4 times X, that's good. So Y is 20. Now, how can we check that solution? How do we know that I've not made a mistake as I do all the time? So to see, let's check it against the budget constraint. Unadjusted income is 90,000, equal to the amount that is spent on X and Y. Coffee costs 6,000 pennies times X plus 3,000 times Y. And our trial solution is that X is equal to 5 and Y is equal to 20. And does that solution work? Does it add up to 90,000 pennies? So the cheap we have 6,000 times 5 or 3,000 plus 60,000 in the second term. And so it appears that we have a solution. 30,000 and 60,000. That's good. So Levi earns 12 points of extra credit in this case, 5 for solving the problem, and 2 for catching my error about 2xy. And everybody else in the class will receive 5,000 of them, sorry, 5 points of extra credit for working on the problem.
Thank you, Professor. Professor, excuse me.
Oh, no, thank you, Specifically Большой.
Oh, thank you, Professor. I'm sorry. May I inquire? Yes. So my answer in the chat is correct, right?
Yes,
Thank you.
X is equal to 5, Y is equal to 20, and we double check the answer. You're going to see the budget constraint.
Thank you.
No, thank you. Okay, so that solves the problem for the given prices of coffee and carrot cake, and also given Anastasia's income. Now, our next problem is to divide a demand function for coffee for any prices at all that we wish to specify, and any income as well. So we want to write down a general function for coffee that depends on the price of coffee and the price of carrot cake and also income. I will specify income as Z in this case. So how are we going to approach this problem now? We no longer have specific values for the prices, but instead we have prices and income that are variable, the value variables. So the solution in this case follows the same algorithm as before. The only difference is people use variables rather than specific values for prices and for income. So we know from the budget constraint that income is a function of the amount spent on coffee and carrot cake, but this time do not specify the values, but instead maintain the budget constraint in terms of variables. And then we also have the condition for maximizing satisfaction. That now looks like this. There, again, we are using variables for prices and income rather than specific values. So the problem now is to use these two conditions to write down a demand function. For coffee. And there I will pause for today to give you a chance to answer the question for class tomorrow. You can work on it overnight and receive again extra credit of up to 5 points per student. Okay, questions so far? Any questions about how we had arrived at revised solution? Questions about what to try for tomorrow and writing down the demand function for coffee. And then once you have solved that problem for additional extra credit, you should write down a demand function for Y. And I will pause there and stop recording.